Hi, this is Rocky. I'm going to explain how the GibbsCam version 8 uh, Parasolid import and hole manager work. I'm going to go click on the file document button, which will allow me to open an existing file. I'll make sure that the files of type drop down is set to Parasolid. Notice all the other file formats that can be read using all the options from GibbsCam, including Pro Engineer and CATIA, etc. We're going to go back up to Parasolid. And it's using X_T extension. Select the hole manager file. Select the 3-axis vertical mill. Solidify, remove unneeded topologies, and simplify are the defaults. You bring a file in. And there's the file. And also down here the size and where the origin is on that. We're going to move the origin momentarily here, but I want to point out, I'm going to bring up the View Control Manager and zoom in on the isometric. Notice how we have the resolution set so that we got some pretty jagged holes here. So I'm going to right mouse click somewhere in the model, go to Properties, and change the faceting resolution over here under the chord height button. Make it something softer than 10 thousandths. This only has to do with rendering speed. It has nothing to do with machining accuracy. Notice we round up those holes. And I'm going to do an unzoom and go back into top view. First thing we're going to do here is move the origin. Right now it's on the bottom of the part here and somewhere not where we want it to be in X and Y. So the first thing I'm going to do with the model selected is turn my edges on and select the corners over here and bring up my geometry creation palette. And one of the options there is working with solids. That's the third icon from the right, and the first button is this geometry extraction tool, and we want to set the tolerance there to 0.01. We'll talk about that here in a minute. And if I hide the model, notice these tools here show or hide the solid. So I'm going to hide the solid. Notice I've got those two lines extracted and their point of intersection. I'm going to do a modify move part origin, and with that origin button, move origin window active. If you hold down the Alt key and the control key, Alt and Shift key, and click on that point, notice it loads the values of the X, Y, Z value of that point I just clicked on, and moves the origin to that point. We no longer need to worry about these features here, so I'm just going to double click, delete them, and bring back the solid model and turn the edges off. And we're going to get rid of the geometry creation palette for just a minute, and we're going back into top view again and select the model. And with the model selected, we can go to our Wizards pull down menu and select Hole Manager. What the Hole Manager does is goes out there and finds the intelligence built into the solid model by the parent CAD program, and this button here, Run AFR, turns on a function called Auto Feature Recognition. And what that does is going to go out there and find everything in this model that represents a hole, or even a chamfered hole or a counterbore hole, as we'll see here in a minute, and reports that data back to Gibbs so we can use it for machining. I want to create a new data set, and I'm going to call this, notice we're putting this geometry into a separate workgroup. The workgroup name is going to be called, by default, AFRWG2, Auto Feature Recognition Workgroup 2. I'm just going to call it Holes for now. And there we go. One CS per orientation. You can add clearance to your holes. You can do some bottom or blind hole bottom adjustment clearances and also through hole adjustments. We're just going to leave all the defaults to 0. And it found 18 holes altogether in this block. And the most effective way of using the hole manager is to group these things into generally process parameters. Machine all like holes at the same time. So we're just going to select process parameters. There are lots of other options here. Same CS or even custom orientations. We're just going to go to process parameters. Click on the OK button, and notice it builds 3 groups. One with 4 holes, and if I go back to my isometric view here and get the hole manager window out of the way a little bit, if I double click on group 1, you'll see that it highlights the 4 holes that are counterbored, the 2 holes that are through holes or reamed holes, and also the 12 holes down the center that are chamfered holes. So let's go back into work group 1. And notice when we double click on that, we have a little button here that says Hole Whiz. That's short for Hole Wizard. We're going to bring up the Hole Wizard. And notice what's going on here. It's told us that there's a 13/16 or 0.812.5 diameter counter bore. Over here, the depth is a 1/2 inch. The overall thickness of this plate is 1 inch. And the through hole down here is 0.531 or 17/32. And over on the right, we have the option of spotting, drilling, or spot facing these things. We'll say next. And we're going to kind of highlight here what Gibbs is recommending. We need a spot drill or center drill. Let's pick a spot drill. We need a 17/32 drill. Notice it's building these tools as we go here. And let's use a rough end mill for the counter bore. So it builds 3 tools and tells us the general checks have all passed, the process checks have passed, and the tool selection is passed. We can just click on that, close that window, click on the next button. And I'm going to bring up my machining processes here. I can build the processes and build the operations. And finish. Now the first thing I want to do here is make sure we don't have a clearance problem. If I double click on the Hole Manager title bar, it rolls up the Hole Manager so I can go in and render this part. And you see we pretty well have a good clearance set up here. I want to make sure that when we import this part, generally when you import a part, the clearance values need readjusted. So I'm going to make sure our clearance values here are back to Z.1, somewhere above the part. And other than that, we're good to go. We've got notice we're dragging a tool across here. So let's go ahead and put some height on these clearances. Going to enter and exit 100 thousandths above Z0 for all 3 of these operations. Okay. And we'll go ahead and redo those processes. And now we see that the selection or the rendering gets rid of the red. So make sure I'm in the flash here. So I render this thing now. We can rotate the part without re-rendering it. So we see we have a nice through hole there and a counter bore with no collisions anywhere. Just like in every other Gibbs operation you're doing, when you have something you're happy with, you want to make sure you get rid of the redo it down here. So I want to click somewhere down below the last operation and make sure that the palette says do it. I can go over here to my process list and delete those 3 processes and go into the second group of 2 holes. And again, we'll bring up the Hole Wizard. This time we have a 3/8 through, the same diameter top and bottom. Spot it and drill it. Say next. All we need to do here, since we already have a spot drill, is just go ahead and put the through hole in, a 3/8 hole. Say next. Build the processes, build the operations. And it's that simple to go ahead and build those holes. We say finish. And without adding a lot of other work here, we're going to go in and go into the Hole Wizard. It tells us we have an angle loading problem. And that's because we don't have a 50-degree chamfer tool selected. So if I go into Preferences, Machining Press, and click on the hole data and tool creation, I can add here a 50-degree chamfer as well as the 45 that comes standard. So if I go back here, click back again, and actually just go back, double click on the group 2 here, go into Hole Wizard. There's our 3/8 hole, top and bottom. Now I can just go ahead and put the 260 or the 50-degree draft angle hole in, create that chamfer tool, and the 266 through hole. And we say next. And notice since we have the operations already here, we just rebuild those processes and build the operations to go ahead and drill and chamfer those holes. I think we're through with the Hole Wizard. Let's go ahead and rewind this thing and play it. Notice that we're showing some red here because if we look at the stock material, this surface is a 1/4 inch below the top of the part there, so we're dragging the tool through. Again, this is the reason why you spend the dollars for a program like Gibbs to catch these things before you go out to the shop and do something that you don't want to do. We should really machine this notch out before we drop those holes in there. So again, we're going to turn the block back on again, and we're going to turn the edges on and find that hole, that edge, and that edge. Bring up our geometry creation palette again and extract those two edges. And there they are. Let's make ourselves a face tool here, a face mill. Go into the face cutter. We'll make it 1.5, 1 inch good, maybe a 3/4 shank, and maybe a 30 thousandths corner radius, and maybe a 1/2 inch high insert, and probably 4 inserts is good. There's a 1 inch out of the holder and a 1 inch out of the holder up here, so we now have a carbide insert, and just call it a 1.5 inch face mill. And with that tool active, we can now go in and just drag that process down and build a contour process. And we're going to start at, again, 100 thousandths. We're going to machine from Z0, and the depth of those slots is, I can turn the solid model on. With the depth box active here, just hold down the Alt key and click on that surface. It tells me that's 1/4 inch. I can also do the same thing by clicking on those two features I just extracted. The same thing would be prudent there. Let's give a 90-degree line of 50 thousandths to turn our cutter comp on, so we have the ability to control the speed or the cutter comp, so we can offset the tool and get control over sizing here. Since these are open terminated shapes, all I need to do is click on the open, the end of the button, and it automatically creates as my start feature, and drag the end feature off a little bit as well as the start point. Make sure it says do it. Click on the do it button, and since we're climbing going up, you might as well climb going back. All you need to do is click on the other end of the other line, and again, give the tool a little bit of clearance off of both sides of the part with the end feature and start point markers. Click on the do it button and close up our geometry palette. Give us a little bit of room here on this smaller screen, and let's go ahead and render it. Notice we're good to go here now. We got rid of that material. Unfortunately, these two operations are out of sequence. They should be up at the start of the program, so we just control select both of those operations and go to the top of the list there. Make sure the little triangle in front of operation 1 turns blue. We can drag and drop those two operations in front of the drilling operations. Let me slow down rendering here a little bit so we can see what's going on. There's our tool and the through hole and the chamfer. And it's that simple to use a solid model with all the intelligence built into it to tell the software what holes we have, whether they're chamfered or counterbored or through holes, and correctly build the correct operations, correct tooling, and machine the solids the way it was intended. Hope you enjoyed this mini training session, and we look forward to working with you. Thank you very much.